All right, it's 10 o'clock, so I think we'll make a start. I'd like to start by welcoming you all. I see that we have quite a full room today, so we're very glad to see that everybody's joining us for this very interesting webinar we've got in store for you. Let me start by saying a big welcome to everybody to this webinar on life cycle assessments for the automotive sector. We are today co-organized by the ALMA and Flamingo projects. My name is Jose Uribe. I'm from the International Solid Waste Association. We do the communications and disseminations for the ALMA project. Our co-host for today is Dr. Yana Katsavu from Excelsis, who do the communications and disseminations for the Flamingo project. I'm very proud to say that we have the support and participation today also of the EnlightEV Cluster, which includes, of course, our two projects, ALMA and Flamingo, and also the projects Revolution, Levi's, and Fatigue for Light. Today, we are also joined by the SALIMA project. All of these projects are receiving funding from the European Commission through the H2020 Innovation and Research Program. So thank you to our sponsors for that. And one of the things that I'd like to start, of course, explaining is what is the EnlightEV Cluster. This is a group of like-minded projects that are focused on what we call lightweighting, which is the concept of trying to reduce the weight of vehicles. This is, of course, a strategy that is useful for reducing the energy consumed during the use of the car. And of course, we do this trying to find either lighter materials that we can use or optimizing the design of the parts, and perhaps also including new materials. So we hope that by lowering the energy consumption during the use, we can also extend the range of the vehicles, for example. And one of the important things, of course, that is another advantage of what we're trying to do with lightweighting is we see that with electric vehicles and as our power grid shifts from fossils to renewables, the largest relative contribution of the use of the energy, of the emissions coming from the use of the car come to the production of the car. And we have a little bit of a problem with either echo or an open mic. So if you could please all close off your mics, that would be useful. Thank you. As I was saying, we want to lower the emissions, and we need to make sure that we don't just focus on the actual use of the car, because when we are all driving electric and the electricity all comes from renewable sources, then of course we have very low emissions coming from the use. So we also need to make sure that for the long-term viability or sustainability of vehicles, we need to focus also on the production side. And at this stage, of course, then we say, well, lightweighting with less mass, this can have a positive impact on sustainability. And in principle, it can also reduce the amount of resources necessary when we're trying to produce the car. And you'll notice that I hedge there a little bit with can have a positive effect and in principle. So the main reason I'm doing this, of course, is because we don't know this until we measure it. As an engineer, one of the first things I was taught was that measuring is knowing. And therefore, if we can see what it is that the effects are of our design decisions, then we can see whether the trade-offs are worth it. Because, for example, what if the energy required for the new production of the new materials exceeds the actual savings during the use or manufacture? This is, of course, where the LCA comes in. The LCAs allows us to measure or to know which trade-offs serve the ultimate goal of sustainability and which do not. One of the things that I stumbled upon while trying to research some of this is, of course, a saying that says, if you can measure it, you can improve it. And this is an important factor, I think, also for LCA, because the LCA is not just a way of maybe proving or trying to ensure that our current design decisions are the proper ones or that they have the proper trade-offs, but also it can allow us to analyze where most of the emissions or the problems for sustainability are coming from, which means that then we can also look more carefully at where do we put our innovation and research efforts into so that they can have the largest payoff when we do resolve the issues that we encounter. This is, of course, very important when it comes to making sure that overall we achieve sustainability. And for this, of course, we also need to know that our LCA approaches and our LCA systems that we develop are correct and reliable. LCA is a rather complex topic, so I will not talk too much about that. That is why we have today all of our experts who will be talking about how they approached this complicated and difficult subject, the assumptions that they might have made, and this data that they might have used, and how that all compares to other approaches from other projects so that we can all exchange some knowledge, maybe best practices, and see how we can bring forward the science of LCA assessments forward. So I'm running out of time for the introduction here, so I will hand you over to Dr. Joanna Katsavo from Excelsis, who I think will tell you a little bit about the housekeeping rules for today and introduce the first speakers. Thank you and welcome all.
Thank you, Jose. Welcome all. Good morning from me as well. As Jose mentioned, I'm Joanna Katsavo from Excelsis, a Greek consulting company. I'm a chemical engineer and the dissemination manager of the Flamingo project. Flamingo is, of course, a Horizon 2020 project that is aiming to the development of lightweight aluminium metal matrix nanocomposites and their validation in green vehicles. Let me start, of course, by saying that I'm very happy to be part of the organizational team of this workshop, as sustainability in the automotive industry, which is, of course, a very energy-intensive sector, is highly important. So LCA assessments and approaches are very crucial and so much needed. Before we start with the presentations, I would like to highlight some organizational aspects. So please make sure to keep track of time as we would like to follow the agenda. We can take questions, always depending on time, either right after each presentation, or I would like to highlight that we have a slot for open discussions as the last item on the agenda. Questions can be asked through the chat, and then me and Jose will collect them and will direct them to the presenters. So please use your name, position, and the presentation or the presenter that you are addressing the question to. And lastly, I would like to let you know that this session is being recorded and it will be available on YouTube after this webinar. So I do not want to delay anymore the workshop, and I would like to give the floor to the first presenter, which is Mrs. Raquel Ledo from the Automotive Technology Center of Galicia.
Hello.
Raquel,
Hello, can you hear me?
Yes, very well.
Perfect. Thank you. I'm going to share my presentation. Sorry, because I have two screens and you can see my screen now?
Yes.
Yes? Okay. So please, if you detect some problem with the sound or something, let me know, okay?
Yes.
Okay, perfect. So thank you very much. Thank you, Joanna. Thank you, Jose, for the organization and for this introduction. My name is Raquel Ledo. I am the responsible for materials innovation area at CTIG, Automotive Technology Center of Galicia. And today I could introduce ALMA. ALMA is a collaborative, ALMA is a collaborative project funded by the European Commission under Horizon 2020 program, and specifically related to the topic advanced light materials and processes for automotive applications. So some general figures. We are 9 partners from 4 European countries, including 5 industrial companies, 3 RTOs, and 1 international association. Our budget is around 4 million euros, and the duration of the project is 3 years. So we have started in February 2021, so we have just entering in the last year of the project. Our main goal is obviously the lightweighting, but we have identified these specific objectives that you can see in my screen now. We can summary in these key points. We need to lightweight, it's clear, but we can't forget the safety of passengers. This is a must. So the material performance should be the highest possible. It's clear that we have to lightweight, but we have to meet all the requirements in the car. We want to decrease the global environmental impact, so we have to apply eco-design strategies to enable effective recycling, recovery, and reuse at the end of life. We want also to promote the sustainability at the circular economy, and it's clear we are in the automotive sector, so all these solutions should be affordable. As I mentioned before, we are 9 partners composed by 5 industries, some big ones as Ford or ArcelorMittal or BAT, some SMEs, is the case of Rescol and Innerspec, 3 RTOs, CTAG, Fraunhofer, ITWM, and TNO, and 1 international association, ISWA. This picture represents the ALMA concept, the ALMA approach, but we would like to go in detail, not a big detail because we have no time, but I'm trying to summarize the work we have carried out until now. First of one, we have the first step was to adapt the structure of a ICE model, an internal combustion engine model, to a BEV model, a battery electric vehicle model. So this was the first step. When we had the first version of this electric model, we start the optimization of design. So there are several key points that we have mentioned here. The first one is that we have to choose the best material for the best location. This is really important because sometimes the materials are really high performant, but we are not putting in the good way. So it seems that it's something very simple, but it's not the case. So it's really important to choose the best material for the best location. The fact of using new high-performance materials allow us to integrate functions. That means that in some cases, at the first point, we had 2, 3, 4, or 5 different components, and now we are able to integrate in one only component. And this is thanks to the typology of the materials, but also thanks to the redesign of these parts. And the last point is really important, that when we are designing this new structure, we are not only thinking to meet the requirement for the function of the car or for the life of the car. We are also thinking what is the solution for the end of the life. So when we are designing, we are thinking in the use, but also thinking in the future. So the main partners involved in these steps of redesign the structure and design BEVSIM tool that I talked before was CTAC and TNO. Then we pass to the point of the innovative materials. In this case, the 2 main partners was ArcelorMittal and Batch. In the case of ArcelorMittal, they have developed high-performance new steels. we are using these new steels in 165 parts in this new body in white of ALMA project. Something, and in some cases we are able to, as I mentioned before, to integrate functions. Is the case of the H-frame or the door panels. So we are able to integrate 2 or 3 components in one only component. And we are using also the structural NMC sheet molding compounds, in this case developed by Batch. And in the usage cases we have select for this is the battery cover and the dash panel. So we have a new design, we have new materials. So our partners, Fraunhofer and Ford, entered in action to develop and to characterize, firstly, these new materials. Fraunhofer has developed the new material cards and compiled all the information and all the required characterization for these new materials. And our colleagues from Ford has carried out all the validation, all the virtual validation, to be sure that this new design with these new materials meet all the requirements in terms of crash, front crash, back crash, lateral crash, etc. It's clear that at the beginning we find some problem and we have to redesign, but now the results are really good. So we have the design, we have the materials, but we have also parallel technologies, we can say. Is the case of the bondable adhesive. In this case, is thinking in the end of the life. So we are going to use this adhesive to join the hybrid components, that is one component from steel and other components from SMC. And the idea is that at the end of the life, by applying high temperature is around 250 degrees, more or less, we will be able to separate, to disassembly in an easy way. And the other innovative technology is concerning the health monitoring. Our colleagues in SPEC are developing a technology based on ultrasounds that is able to determine the condition of the part. So we will be able to determine if this part could be reused, or we have to recycle, or we can choose what is the function at the end of life. So this is in general all the approach we have in ALMA project. At this point, with the work we have carried out until now, we can say 2 main results. One is the BEVSIM tool that my colleague Tom will explain in detail. I think it's really a very useful tool that can help the designers to take into account the LCA and LCC parameters to have a better design of the part. But Tom will explain in 5 minutes. And I think I pass. Yes, in this point is the other good point is that we all work carry out. We have reached a lightweighting potential, a potential lightweighting of 23% of lightweighting concerning the baseline. So we are really happy of this at this point. We think that the potential impact we can have in the future vehicles is really important. So now in this last year of the project, we are we are focusing in the manufacturing processes. That means that we are going to develop some demonstrator parts in steel and in SMC to check the results we have obtained in the virtual validation, and to check the feasibility of the parts with these new materials. But we are really confident that this point is really good and with a high potential for the new vehicles. So from my part is all a brief introduction to ALMA. I really want to thank to all consortium, all partners involved in EnlightEV consortium, because I think the fact of sharing results between different consortiums and from different projects is really important. This webinar is one sample for this. We have developed some activities during this last year, and we will have more joint activities in the future. And if you want to know more about ALMA, please don't hesitate to contact by social network, by our web page or something else. So thank you very much. I think I have respected my time, my slot, and it's all. Thank you.
Thank you, Raquel. I think that we can pass to the next presentation, and then we can have all together questions maybe for this part, as it refers to the ALMA project. Is this okay with you, Raquel?
Yes. Mm-hmm.
Great, great. So I would like to invite Mr. Tom Lichthart from TNO to present the BEVSIM tool.
Yeah, and thanks, Raquel, for already introducing it. So let's see. Is my presentation visible now? I think so.
Yes, it is.
Yeah, okay. Yeah, the BEVSIM tool, it's the result of a team of TNO, and of course also input by the partners to fill the database. I will be presenting it today. I'm Tom Lichthart, Senior Scientist from TNO and RTE from the Netherlands. And I'm going to show you some things on the BEVSIM tool. So first a short introduction, and let's see what the capabilities of the tools are, and first kind of simulation of the workflow. And after showing the results, I'll end with some closing remarks. BEVSIM, it looks over the full life cycle of a battery electric vehicle, and BEVSIM stands for Battery Electric Vehicle Sustainability Impact Assessment Model. It's an LCA model, so you can really do an LCA with this tool, as all the materials needed for the production of a car, the processing of the materials into parts and choices to be made for the use phase, the end-of-life fate, and the end-of-life recycling processes can be made, and we are aiming at the segment C and D passenger cars. It can be customized BEVSIM, so you can model a full car or include or focus on a subsystem like the body and weight, or even go to designing a part and comparing that with reference parts, for instance. There is also the possibility that the customer includes its own specific data sets. The results, you can download these as a Word report, but also in an Excel workbook. And of course, the benefit of an online tool is that we have the version control, and that we can easily update the lifecycle inventory data sets, but also the methods included in BEVSIM. And so with this tool, you are able to do the full LCA, and so really have a fast result, and also people not specialized in LCA can do this. It's designed for the non-LCA experts, like the designers of parts, materials, and complete vehicles. The capabilities of BEVSIM, it has let's take a pointer. It of course has an LCA part, but also life cycle costing, LCC, and a circularity assessment. And later on, with Jimena, of global factor, I will present something about circularity in the automotive industry. So you can see what is the impact of the lightweighting, the measures that you take, and see what are the effects of material choice, but also, for instance, the use phase. In which country are you taking your electricity from for charging your car, and are you using gray or green electricity? Also, future recycling scenarios have been included in the end of life, so you can also look at the future end of life performance. Then all the life cycles phases are included, so the raw materials, all the things you need to make a car, and also the processes to make parts of these materials. And plastics is included with compounding, injection molding, and also, of course, metals with the stamping, casting, all kinds of processes, and also the painting and the assembly of the car. As said, in the use phase, you can look at the energy consumption of the car, and it depends, among others, of the weight of the vehicle, and that's automatically included already. But also maintenance is included, and changing of parts during the life cycle. In the end of life, the current scenario is there, but also a future scenario. Recycling, but also energy recovery that avoids the production of materials and energy. That is also part of this tool. You start with BEVSIM by first selecting a user design. There are already some there, and you can then select it, and further on can edit this this user design. But you can also do it at the subsystem level, for instance, body in white, or even a part level. I said also LCC is part of the tool. There is a database in it with default material costs. Also, user costs are included, so that's the consumer. And you can edit these prices to suit your own needs. And then in the user design, well, as said, you can select the type of electricity or fuel in case it's an internal combustion engine, select consumer price, and other cost elements. That's then all used in both the LCA and the life cycle costing. Then, oh, this was going too quick. You can edit the user design that you've chosen. You can save it under another name. You can add or delete parts, and also with those parts, you can select the materials, change it. You can select up to 3 different processes to model the material into a part, and also their efficiencies are taken into account. So, well, you only have to give the amount of material in the actual part, and the tool will calculate the final material needs. And it also accounts for the recycling, treatment of the production waste, but also the end-of-life waste. That's all included. Then you select up to 2 different reference designs with which you then can compare your own user design. And well, you then select the use phase methods. For instance, which counter do I take my electricity for the consumer from? Is it gray or is it green electricity, as that will affect the performance in the use phase. The end-of-life scenarios are then selected. There is a current reference scenario, but you can also have future scenarios in which we have chemical recycling for the plastics and the sheet molding compounds, because they can become more and more important, of course, in the automotive industry. Yeah, here is just a selection, a comparison of two different designs, battery electric vehicle and the internal combustion petrol car. Yeah, what you do in this case, well, body is the same weight. The chassis of the battery electric vehicle is heavier, and of course also in the powertrain, because the battery is there is a higher mass. But indeed, so lightweighting of these electric vehicles is of importance. Then you can evaluate the sustainability impacts. You have a spider graph comparing your up to 3 different cars in the spider. With, in this case, we show the impact categories of recipe, a much used environmental impact assessment method. But what you can also do is that you go to a bar chart. To a bar chart, and then, for instance, if you're looking at the parts level, you can also have a look at the subsystems or materials, but here an example of the parts level is shown, and then you see what is in the materials, what is in the assembly, end of life, etc. That's all shown. And so that's also a way to look at it and see where my hotspot, my most important impacts are. Then for the life cycle costing, we have two perspectives, that of the consumer. So the price that the consumer has to pay for the vehicle, but also the other costs like taxes and energy cost. And in the end, you might have, for the end-of-life vehicle, there might be some revenues. So that's included. Also the producer's perspective, and there you see material costs, processing costs, but also costs that have to do with, for instance, callback actions, and of course the revenues. That's also a possibility to do. And this then for the consumer, of course, the purchase costs are the most important ones, but these are costs from the use phase, and that may be taxes, but also energy costs, and there can be some small revenues at the end of life. And then you see the total life cycle costs for the consumer. So that's also a thing which you can take into account. For the producer, that's again, things like the manufacturing costs and other costs, and of course the revenues that come from the sales. Some closing remarks. So it's BEVSIM. It's an online tool with which you can assess the environmental impact via LCA. You can assess the circularity, show it more on that later, and also the impacts, economic impacts. Also have the consumer perspective, which might be a kind of sales argument if you have a better performance there, for instance, in the use phase. It's specifically designed for non-LCA experts in the automotive sector, And as said, you can model a whole vehicle, but also parts. And the tool gives consistency above, over all the LCA studies that you do. BEVSIM is also accessible for third parties, and we can have a discussion for that on a case-to-case basis, and that can also be a modification of BEVSIM. Then, so this is the end of my presentation. I'll present you the ALMA team. Originally, Rajesh Mehta, but he had to leave TNO, was the work package leader for this. Now I am the leader, and these are the other people that contributed to the filling and designing, constructing the BEVSIM tool, and also to get it as an online tool available for others. As said, we were funded by the Horizon 2020 project, and we had input from our partners in the ALMA project. So, as already said, it's also an introduction is also available on YouTube, and of course you can contact me for further details. That's my presentation. So I don't know whether there are questions.
Thank you, Tom, very much. Indeed, there are questions for both you and Raquel. So I will start with a question for Raquel, since we have some time. It is from Ignacio Zurano from Lomartov to Raquel. Congratulations for the presentation, and he would like to know more about the energy consumption that this process that you're developing has, comparing with the baseline.
Yes, I have just answered by the chat, but I repeat, it's very simple. If we talk about the energy consumption for the global vehicle, for the functioning of the vehicle, we talk about 6% more or less of energy reduction. But we also can talk about energy consumption in terms of manufacturing processes. I talked before that the new high-performance steels allow us to reduce the thickness of the parts. So the energy we need for manufacturing these parts is lower. The fact of being able to integrate functions allow us that instead to manufacture 2, 3, 4 different parts with 2, 3, 4 different tooling, now we are joining in only one, so we are also reducing. But it's true that at the moment we have not quantified this reduction. But we have the two ways: the global energy consumption, 6% more or less, and this other that I have not a number just now.
Excellent, thanks.
Thank you.
Thank you, Raquel. So the next question is for Tom. It's from Maria Wellmuse Henriksson from Volvo Buses, and they're asking, could BEVSIM tool be used for heavy-duty vehicles, even if it is designed for passenger cars?
Yeah, that's in principle, that's possible, of course. You will have to further define the parts of that vehicles, and in case other materials or processes are being used, these also have to be included. But that's all possible to customize BEVSIM for a specific use. And what you could also think of, that manufacturers of the original equipment, they want to focus on parts, also need more specific materials. That's also a possibility in BEVSIM.
Thank you, Tom. So one more question for you from Carla Barbati from Constellium. The question is in the part of the processing of metals, is the extrusion process included in the BEVSIM tool? And also if which metals or alloys are included? Is it aluminium alloy included?
Yeah, aluminium is there, and of course also processes like the extrusion. So for each material, there is a set of for material specific processes. So once you have selected a material and you then want to go to the processes, you only see the processes relevant for that kind of material, and there are different types of steel in the BEVSIM tool. And also for sheet molding compounds, we have 2 different types that are being developed in the ALMA products. These are also included in BEVSIM. And perhaps coming back on the question on the energy consumption, we have the cumulative energy demand as an impact assessment method in BEVSIM. So you can also see what is the cumulative energy demand related to materials, processing, use phase, etc.
Thank you. Great, Tom. So we have some time for some more questions, so we'll proceed. The next question is regarding the functionalities for inputting real-time production data. Are you planning to include such functionalities in the tool?
Yeah, real-time production data can be included in the database, so not really real-time, but once you have data that you collected in real-time, that can be included in the tool, and so that can also be kind of overall processes that are there for the whole car.
Okay, great. And as we are all familiar with the LCA software like Sigma Pro, what is the difference using this tool compared to the traditional ones?
Yeah, so this is really a tool that is, as the main audience, see designers that are not familiar with LCA software. And as I showed, you can edit a design that's already there, change a part, use other materials, and select the processes needed to form it into a part. So that's the main difference. That it's you don't have to be really a Sigma Pro or Gabi user. You can do it with this BEVSIM tool.
Okay, thanks. And one more question from Angie from the Salient Consortium. Is this tool for commercial use?
Yeah, it can be. You can get a license from us, and at the moment, yeah, we have to see that case by case.
Okay, yeah, you have the contact details, so if anyone is interested, they can contact you directly.
Sure, yeah,
I guess.
Indeed.
Okay, great. And from Mattia from EcoInvent Association, do you also include the emissions due to brake, tire, and road wear?
Yes, these are in the use phase. Yeah.
Okay, great. You have been bombarded with questions, so this means that the 2 first slots were very interesting. Sorry for that. I will come continue. Can you clarify the LCA methodology you used regarding allocations for recycling, like recycled content versus the end-of-life recycling approach?
Yeah, it's basically what we call also system expansion, and that's translated into subtracting the avoided impacts, for instance, due to energy recovery or due to recycling. Those are then subtracted, so that's a benefit for you. And there is, it's the full benefits are then accounted to the car, to the vehicle. But if you want to have another type of allocation method in that can be included, and perhaps also important to say, we look at the quality of the recycled material. That's also accounted for.
Great, thanks. And one question for Raquel from How, from ISQ. For the adhesive bonding of multi-material components, are you considering analyzing different types of adhesives, or is it limited to one adhesive only?
No, the plan in ALMA project is to use the adhesive developed by Rescol, is the partner in charge of developing this adhesive. So in this case, we are working with this type of adhesive exclusively. And it's working well.
This is great. Thanks. And for Tom, is the tool able to consider the different types of joining techniques?
Yeah, so there is welding, and also, for instance, with the battery lid, there will be a reversible bonding. We will get the details of that, and then it will be included in the BEVSIM model.
And one more last question for Tom as well. Which database engine supports BEVSIM?
Yeah, so of course, the database, you have the lifecycle inventories, it's industry data, it's also EcoInvent and other databases, data by World Steel. But perhaps the database of the tool itself, it's developed in R Shiny, and with that we are able to present it as an online version via the Diamonds platform of TNO. I hope that answers the question.
I hope as well. And one more question arrived just now. If you are planning to extend the LCA framework analysis for other technologies like electric vehicles,
Yeah, this of course, this is the C&D passenger car electric vehicles, but it's also possible to have an electric bus, for instance, in BEVSIM, and compare that with the unconventional diesel bus.
Okay, great.
Good.
So I think we have concluded with the questions as well. So I want to thank you both for the presentations and for taking the questions now.
Yeah, you're welcome.
Thank you, Raquel. Thank you, Tom.
Thank you very much.